Hi, my name is Anudeep and I am the founder and CEO of Sidebrain, where we use language to create a self-organizing memory model for your content. Today I'm going to show you how you can use Sidebrain and add pieces of the internet into it. So I'm on some random blog page and this is what the Sidebrain plugin looks like. Fairly simple. You can add content here and type content here and send it in. We have taken the approach of a messaging UI because the human brain, it thinks in these really short message formats. It doesn't think in a long form note. So if you're on this page and you just want to quickly capture it, you can just click on this button and it gets captured in. If you can make it into a thread. So this is a parent and then you can add this looks into it. You can also annotate. So I can take this and I click on this, it gets added as an annotation. Another cool thing that this does is it recognizes when content is already there inside your Sidebrain to avoid duplication. So this is a page that I've gone to and I've added a bunch of content. So now if I just select this section and click on this, you will see that it's added it to something that already exists, because as you can see it's a thread that goes much longer. And then you have basic functions like being able to delete and everything. You can also search here. So for example, I can search for Y Combinator and a bunch of stuff shows up. The Hacker News article being one of them, and then a bunch of other things. You can keep adding multiple selection options. So it essentially reduces the universe of things that it is picking up. Once you've added things in, we translate that into a graph database. So this is the interface for Neo4j, which is a graph database that we are using in the backend to connect all of the data together. A graph database differs from a conventional database in the fact that relationships between data are a first-class citizen. So just to show you how the data model looks like, this is it's the same data that's being shown. So this is the parent, good keyword extraction algorithms, and there's a bunch of stuff underneath it that are all children. So I can click on this. If I do this, I'm gonna go full screen so it's a little easier. Blue is a parent, as it shows here. All of the pink stuff are children. And each one of those children are essentially each one of these pieces. Now, all of the content that is a link has metadata that is associated with it. So for example, this has this entire piece of text that is the metadata that you can literally use to organize your data. So we have a very high we place a very high level of importance on metadata. So we connect this up with its metadata. So as you can see, the gray stuff is the metadata. And then we do additional things like checking out what the domain is, and we do this for every piece of node. This starts looking really interesting when you start seeing this more at an aggregate level. So this is a small cross-section of the data that I have ingested. As you can see already, interconnections start showing up in the data. The clusters start forming, and this is because the interconnections in the data are a first-class citizen. And this is very aligned with how in the human brain, the intelligence is how the neurons are connected, not just in the neurons themselves. You can see different sections forming much higher levels of connection here. And then if I increase this, I'm still only showing you a small cross section of the data. You will start really seeing just how much connections are embedded into the data. And I haven't added any of these things manually. Using just the content that you add here, I am constructing this data up. So this is a small, about like a 1/4 cross section of the data in my Sidebrain. As you can see, clusters start forming. There are certain nodes that are connected across really far distances. Very similar to how in the brain, like certain nodes are connected to literally the other side of the brain, and creativity, in a sense, is the connection of ideas that are very far away, but they're connected by a node. So like this is represented in the data. Next, I'm going to show you how we traverse this data, because obviously it does not make sense to traverse this using the knowledge graph. Although we haven't really given up on that idea, because it is incredibly cool to be able to visualize the data that you have added as a graph. It really starts to show how complex and how intricately complicated and interesting you are as a person just based on the data. So I will show that in a second. So the knowledge graph that I showed you in the previous section was constructed using linguistic rules. So whatever text that you added, including the metadata, was parsed and then tokenized, and then the words that have not a lot of meaning were discarded, and the words that have particular depth of meaning were maintained, and those were used to make the connections. To traverse the knowledge graph, we're using a text-based interface where it's kind of like you're literally talking to your data in the form of a sentence. So I built a simple command line interface to prototype how an exploration of your knowledge graph could look like. So if I press E, I enter into a path where I can choose what I want to explore, whether I want to explore the verbs, nouns, proper nouns, or adjectives. Let's say I want to start off with proper nouns, and I want to see 100 elements. So like here, it's showing me 100 elements with their index, and I can add the element into my selection by just entering their index. So here, you can start seeing how my interests are reflected in the number of connections. RNA, NLP, GitHub, Python, Twitter, like these are some of the things that I spend a lot of my time in, and that is why they show up here. So I'm particularly interested in RNA, so let's just go with that. And then, instead of just completing the selection, let us see what other choices are related to the choice that I just made. So if you see here already, just based on that one choice, the next level of choices are showing up, which are all related to RNA. So this is an messenger RNA, mRNA, DNA, transcription, tRNA. All of these things, I did not program it in, but the connections amongst the data means that relatively similar words start clustering together. So let me add mRNA, let me also add DNA. And let me complete my selection. And then let's say I want to go in and see some nouns. Okay, here, again, you can start seeing the things that are the most interesting for me. I read a lot about the brain, DNA, Sidebrain, time, Reddit, and all of these things. So I'm interested in cells, and let's say code. Let's see what are some of the related choices. Oh, interesting. Decorators, DNA, machinery, oncogenes, telophase. You can see how they're all the interconnections, the relations start showing up. So let me add reproduction, let me add protein. Let's just do this, and then let's complete the selection. And what you see here is all of the things that are in my Sidebrain that match my selection. Now this is fairly, I just made this to show how this would work, but let me just copy this into the So what that returned essentially is this. As you can see, the interconnections in the data are all there. I need to find a better way of displaying this data to the user, but this is a very brief demo of how Sidebrain is constructing a knowledge graph. We haven't yet gotten into building language universes yet. That comes next. We're initially starting off with building self-assembling knowledge graphs and then using that to start categorizing your information. Thank you.